So good morning, everyone. Thank you. Good morning, everyone. Thank you, Varya, for introducing me. And I welcome all the students, teachers, mentors, and faculties of different colleges or prestigious colleges to join in for this session today. And today that we'll be discussing about unmanned aerial systems and their classification by weight, range, and types, some of the DGCA rules, and then some degrees of freedom. So that will be the timeline, and I will be now starting the session very quickly. Let's just get in directly. And there we go. So I hope you are able to see my screen. Is that okay? Give me a yes.
Yeah, we can see it.
Sure. So we'll start with 6 degrees of freedom. So if there is an aircraft or any moving vehicle in the air or any vehicle that is airborne will possess 6 degrees of freedom. That's a basic. So let's proceed further. So in total, there are 3 pairs of freedom. Two sides is of roll, 2 sides of pitch, and 2 sides of yaw. So let's consider this as an aircraft in front of you. Let's see how rolling is done. So that's rolling. Okay. That's pitching of any aircraft. And that's yaw. Right? So there are 3 pairs, so total 6 degrees of freedom. Let's get ahead. Let's see roll, pitch, and yaw on all the 3 views of the aircraft. That's roll. That's pitch. And that's yaw. Okay, let's get ahead. So in the case of a drone system, these are 3 uh, roll, pitch, and yaw. In case of a drone, wherein the shape is let's say a very symmetrical, roll and pitch become same. I mean, in case of dynamics, when we calculate, roll and pitch become same. But the drone shown here has different symmetries. So in this case, roll, pitch, and yaw is not same, it's entirely different. Again, I will repeat that point. If in the situation wherein the drone shape, the central shape, the center pivot is symmetrical in both the axes, in that case, roll and pitch is same. Otherwise, in the case of wherein the drone size is not symmetrical, roll, pitch, and yaw are different. In case of dynamics, in case of system attitude and control. Okay, let's proceed further. Let's get to the next chapter. Lift on a wing. So how does a drone fly? Or how does any aircraft fly? Or any unmanned aerial system or any system is able to fly? So there's supposed to be something which keeps it airborne. What is it? It's basically the lift on a wing. Let's see how a lift on a wing is seen. So consider this as the propeller blade. This side you see is one blade, right? Over this blade, I'm trying to show you particles of air traveling. So once it reaches to the top of the this airfoil, the speed of air is increased, and the speed of air below this airfoil is slower. In this situation, for the students of 11th class students, if you know about Bernoulli's theorem, you will be able to understand that due to this phenomenon, the speed of air being higher at the top of the airfoil as compared to the under of the airfoil, there is a pressure difference. In this situation, there is an upward force that is exerted onto the airfoil, which creates the aircraft to be able to fly. So if in this case, if this airfoil is as is in your screen, in this situation, this airfoil, if rotating in counterclockwise direction, would want to come towards you. Okay, would want to come towards you. Why? Because the air speed over the top is higher as compared to the beneath of that airfoil. Thus, there is a pressure difference, and because of that, that pressure difference, the airfoil wants to come towards you. Okay, let's go ahead. So these are three airfoils I'm trying to show you in three different. One airfoil in four different situations. In the first situation, there is no lift over the wing. There is a lift, but not that great that the aircraft would be able to fly. Although the speed of air traveling above the airfoil is faster as compared to beneath. In this situation, there will be an upward force. That is true. However, that is not enough for this airfoil to create a lift such that the aircraft would be able to go airborne. In this situation, we pitch the nose of the aircraft upward such that the air speed going above this airfoil increases as compared to below. And also because of the thrust and because of the air colliding with this aircraft, with this wing, there is a lift force in this direction, in the upward direction. Although there is a drag also, but there is a lot of lift force in this direction. In that situation, the aircraft will be able to fly. It will be able to take off. Once it is taken off, now the aircraft has to go into a cruising altitude or a cruising path. In that situation, and wherein the situation, once you go higher in the altitude, your pressure will decrease. The air pressure will decrease. In that situation, this aircraft needs to have more lift, and so more interaction of air is needed with its wing. Thus, it has to pitch a little bit higher to go into that altitude. So many times you must have seen while sitting in the aircraft, the lights are turned dim and you're not asked to move into the lobby. And if you try to move towards the cockpit, you will feel a gravity force behind you. I mean, the gravity would try to push you down and it will be very difficult for you to reach the cockpit if you have to walk into that situation. Although it's not allowed, but just imagine that case. So why is it done? It is done because of the fact that the aircraft has to go into a cruising altitude. For that reasons, it is done so. In this situation, the last situation, this is called stalling. In this situation, maximum drag is created. There is no upward lift. If the aircraft nose is made in such a way that is pointing directly upward or maybe about 87 or nearly 90 degrees, in that situation, the aircraft would stall. It will not be able to travel, and there is no lift created over the wings, and the aircraft would stall. So that's a very deadly situation. So there is a particular limit amongst which the pilot can pitch up and pitch down. Other than that, it's very difficult. Okay, let's go ahead. So what is a drone or unmanned aerial system? So by definition, an unmanned aerial system or UAS is defined as a powered aerial vehicle that does not carry a human operator, uses aerodynamic forces to provide vehicle lift, and can fly autonomously or be remotely piloted. That's a basic definition of an unmanned aerial system. What are the major components of an unmanned aerial system? There is a flight controller, there is a navigation module, there's a communication module, there's a power system, there are batteries, there is a thrust system, propeller based or turboprop based, and there are strobe lights to indicate that something is flying in the midnights or after dark, after the sunset. Let's get ahead. So what are the classification of unmanned aerial systems? Let's start with classification by type. So there are three classification by type. One is single rotor. In this case, main wing provides thrust and lift, and it's less endurance, hovering opportunity, and can reach far-flung areas. Far-flung areas, for example, you cannot land an uh, entire aeroplane very quickly in any region in the Himalayan region. But in case wherein you have a helicopter, you may hover, or in other opportunities, you may land also your helicopter in some areas wherein you find a flat land. All right. But in otherwise, you cannot land aircraft in such situations. So that's a opportunity of a single rotor. What are the opportunities of multi-rotor? In case of multi-rotors, all rotors provide lift and thrust. More rotors provide more thrust and stability for hovering. So if in case there is a quadcopter, there is less stability, and in case of octocopter, there is more stability. There is also a certain limit above which more number of propellers will not provide much stability. It will be more or less the same. But in this case, since there is a lot of power used to lift the aircraft, a lot of thrust is used to keep the aircraft flying. In that situation, less endurance is seen, but at the same time, great vertical speeds are also seen. Then there is fixed wing. In this case, lift is from the wing, and there are multiple design opportunities that you can harness while you're designing a single fixed wing aircraft or multi fixed wing aircraft. So in this case, small size don't require a runway. It's in situations wherein there is less far-flung areas, you may just be able to land your aircraft into a simple grassland, a small grassland area that you can do. And in the other case, there is high speeds and supersonic speeds are achievable in case of fixed wing. But it cannot hover. Up and until it does not have an propeller which is straightly pointing upwards. In that case, you can hover, but otherwise you will not be able to hover if you have a fixed wing. And then there is the last one, which is called the hybrid. These are new things. In hybrid, you may connect this one and this fixed wing one together. These are called VTOLs, or vertical takeoff and landing aircrafts, and such are their designs. And these are the other designs these days you might be able to see. And these can hover. In this situation, it can fly as a fixed wing, and it can hover also in one place. Let's proceed further. Then there is classification by weight. Let's get ahead by weight. By weight, the simplest classification that I can explain you is with this. So below 250 grams, we call it nano drones. It's a simple one bowl of rice. Between that and up until brick weight, which is 2 kilogram, we call it micro. Above that, to less than 25-liter industrial superior kerosene oil, it is called a small drone. Above that, it's called a medium drone, which is weight of a cooler. And above that, above 150 kilogram, every drone or unmanned aerial system is called a large drone category. Let's proceed ahead. There classification by range as well. There are 4 classification which I come up with, usually the way I teach. You may come up with the other classification as well, but that's a broader aspect. So one is LACE, known as low altitude short endurance. Then there is LAIL, low altitude long endurance. Then there is MAIL, medium altitude long endurance. Then there is HAIL, high altitude long endurance. Let's get ahead. So that's the last part of this presentation. If any questions anybody wants to ask this, please make it. I will go to the next part of the presentation. If any questions are asked, they are welcomed. Let me go to the next part of this presentation, which is 3. Any questions up until now? Any questions? No. Okay. Let's proceed further. It will take a bit time. Yes. So let's discuss about the drone rules 2021 and Digital Sky DGCA. A little bit about them. Let's discuss about them a little bit. So I've given here a link, which is called the Director General of Civil Aviation, GOI, Government of India. Let's go ahead. So by definitions, there's something that are defined when you try to fly an aircraft or try to fly an unmanned aerial system. And these definitions must be known by every pilot and every student who's actually trying to pursue a career in drone development. So what is an accident? Accident in any incident associated with the operation of an unmanned aerial system, aircraft system, in which a person is fatally or seriously injured, or where the unmanned aircraft system sustained significant damage or goes missing or is completely inaccessible is called an accident. So these are basic definitions. So what is a drone acknowledgement number? So drone acknowledgement number means a unique number issued by the Digital Sky platform under the voluntary disclosure scheme of unmanned aircraft systems in India. So any aircraft or any unmanned aerial system that you will have or possess or manufacture will be associated with a drone acknowledgement number. For that, you need to register yourself on DGCA, Digital Sky platform. So what is geofencing? Geofencing means restricting the movement of unmanned aircraft system within a defined airspace. Okay, let's proceed further. So there are zonal classifications. Airspace of defined dimensions have land areas or territorial waters of India. So there are 3 zones amongst which one has to follow or I mean, there are 3 permissible zones or non-permissible zones which you have to be very much aware of while flying an unmanned aerial system. So the first is the green zone, which is up to a vertical distance of 400 feet or 120 meters that is not being designated as a red zone or yellow zone in the airspace map for unmanned aircraft systems operations, and the airspace up to a vertical distance of 200 feet or 60 meters above the area located between lateral distance of 8 kilometers and 12 kilometers from the perimeter of an operational airport. So that's the definition of a green zone. Then there is yellow zone, which is the area within which the unmanned aircraft system operates are restricted and shall require permission from the concerned air traffic control authority. The airspace above 400 feet or 120 meter in the designated green zone, and the airspace above 200 feet or 60 meter in the area located between the lateral distance of 8 kilometers and 12 kilometers from the perimeter of an operational airport shall be designated as a yellow zone. Then there is finally the red zone, or any installation notified port limits specified by the central government beyond the territorial waters of India, within which unmanned aircraft system operations shall be permitted only by the central government. So no other way you can or anyone can fly. It's just the central government permissible area. Let's proceed further. Then there are certifications of unmanned aircraft systems. How do we certify them? First is the type certification. This is issued by the Quality Council of India. Then the certificate standards issued by Quality Council of India. Then there is one thing called as import regulation. Director General of Foreign Trade does that. And there are mandatory safety features. So no permission, no takeoff, hardware, firmware, real-time tracking beacon that communicates the unmanned aircraft system's location, altitude, speed, and a unique identification number. Then there is geofencing capability. All of these are required when you fly your drone. It does not matter. It has, if you're a startup or something else, if you are flying a drone, these mandatory safety features have to be there, even for a student of ATL. Okay. So what are the exemptions? No type certificate shall be required for manufacturing or importing an unmanned aircraft system. No type certificate shall be required for operating the following, namely a model remotely piloted aircraft system and nano unmanned aircraft system. So below that category, and a remotely piloted aircraft system, which is a model. In this case, you may not be able to, you are not required any type certification or permissions also. So in situations wherein you have a tethered drone, and in case of tethered drone, it's permissible to fly in the green zone, you may fly that without permission as well. Okay, let's proceed further then. So operations, facilities, and compliances by government. So what are those? What should be all those permissions and operation compliances or laid out by the government? So there is an airspace map which is provided on the DGCA website, Digital Sky platform. Then there is interactive map, mandatory pre-flight verification of zonal restrictions. This is the API you need to work with. Requirement of prior permission that is required from every ATC near about your region of airspace. Right of way is required. Carriage of dangerous goods, it has to be very much taken care of. You should not carry any puffed up batteries, or your battery should be under, one should say, under very good observation and should be very good in operational range and should be able to endure your entire flight time, which you have thought of. Then there is dynamic nature of zoning, temporarily red zone, access to digital sky platform, safe operation, prohibition of carriage of arm, ammunition, explosive, and military stores, etc. Mandatory reporting of an accident. So as I said, the accident definition earlier. So if in case you have an accident, you will have to report. Otherwise, you will be under jurisdiction very quickly of that area. I mean, authorities will come to you immediately in that situation. So exemption for research and development institutions. Any research and development entity under the administrative control of or recognized by the central government or state government or unitary administration are exempted to do research and development on drone systems. But with the fact that they are doing it indoors, not outdoors. Any educational institutions under the administrative control of or recognized by the central government or state government or unitary administration. Any startup recognized by the Department of for promotion of industry and internal trade. Any authorized testing entity. Any unmanned aircraft system manufacturer having goods and service tag identification number. So all of these people are exempted to do research and development on unmanned systems within a specified green zone, and if they are doing it indoors, they are exempted from these from those restrictions. So that was part 3 of of this today's session. Let me just go to the last part of today's session. So part 4 will be airworthiness. We'll discuss about airworthiness. That's it. So basically for marketing, what are those basic quantifiers or key performance indices, or I may say, what are those points that one needs to ponder upon for saying that your aircraft or my drone is airworthy, right? So these are those factors you may go through once you manufacture a drone or once you assemble your drone. So the first question is it safe to fly? How much is the flight time? What is the all of weight? All of weight implies that you may increase the weight on your drone, and if you are able to lift it up, that is your all of weight. If you're not able to lift it up, that weight before that weight is your all of weight. Okay. And what is the speed of your unmanned aerial system? How far it can go? What is the range of your system? How much is the thrust? What is the motor torque? What are the battery C rating? What is communication frequency? What is signal range? What are your wind resistance? How does it handle wind resistance, wind turbulence or wind gusts? And what are the electronics and controllers on board or over the board of your unmanned aerial system? How much is your airframe stable? Will it go? Will it crack while it's flying? All of these questions are asked. So the left part is for the marketing, the right part is for engineering. Oh, wait. So there are four basic factors that define your airworthiness. One is control, then is thrust versus weight, then there is power, then there is airframe. Okay. In case of thrust versus weight, thrust mechanism, bulky design versus lift, lift on airframe, lift on wings, sweet spot between wingspan and thrust, fuel efficiency, and fuel residue. So these are the basic factors which need to be thought of while designing an unmanned aerial system. In case of airframe, how light or how much heavy is it? What are the material or composites used there? Is it metal? Then is it tested in CFD for aerodynamics? Is your system validated? After that, wind tunnel testing and validation is done. After that, speed limit testing is done. How far it can go. And then there is actuators for control surfaces. So what are control surfaces? I didn't talk about them. Let me give you a small hint. In case of an aircraft, when you have to roll and pitch, you use ailerons and you use rudders for attitude and stability control of the aircraft. You can just go on internet and search for them. What are those? And you will be able to understand. Those are called control surfaces of an aircraft. Every aircraft has, every flying unmanned aerial system or anything like those has those things available on their design. In case of a drone, there is no rudder. In that situation, we use PID controllers to make it stable while it's airborne. In case of control design, what are the electronics that you are using? How quickly does the message flow between those electronics? Or signal flows between those electronics? What are the control surfaces? How is your drone navigating? What sort of software are you using? How quickly your system, you're able to control the attitude of a system? How high it can go? What is the altitude limit that your aircraft or system can go? How much stable is your system? So in case wherein you may find that the drone is flying in a greater height, in those situations, the air speeds at that heights are very higher. So in that situation, the drone might flip and then it might crash or might fall. So all of those things has to be thought of while designing an unmanned aerial system. In case of power, what are the electrical batteries that you're using? What is the C rating of those? Are your batteries puffed up? Are your batteries tested before flying those systems? Have you tested your motors with those batteries? All of those questions come into mind. What are the mechanical systems and what are the ecological barriers? When we say mechanical systems, it basically depends upon the motor speed and motor torque. When we talk about ecological barriers, in situations where you have a lot of birds flying zones, or let's say suppose you're flying your drone in the month of September or October in Delhi, wherein you have so many dragonflies flying around. In this situation, anyone might collide with your drone and might, just create a dip in its flight altitude all of a sudden. These many situations have to be thought of while designing an unmanned aerial system. Okay, let's proceed further. So, for example, you have this bee in front of you, right? How does this bee create lift? So it's because of its flapping wings very quickly. In a second, it's flapping its wings very fastly. In that situation, the bee is able to lift up from the ground and is able to fly. And how does it navigate? So it basically turns in one direction. Once it does that, by flapping one wing a little bit faster than the other, it has a lift in that direction. So if you see its design of its entire body, that's its design. I'm trying to show it in 3D. What happened? Huh. And you see the shape of this bee. It's basically very aerodynamic in nature. If you see the shape of a bee or a wasp, it's very similar to each other and it's very aerodynamic in nature. Think over those design as well. How does any engineer think of small nano drones and micro drones these days? These are the spaces from which they get inspiration. And that's your aircraft. That's his entire design. So these surfaces, I mean, I just clicked it. Sorry for that. These surfaces are called, this is called a rudder, these are aileron, and so on and so forth. Okay. I'm hearing some noise in between. Please, you could turn off your microphones if somebody is using. We still have time, right? It's 12:02.
Yeah.
So in case of power, sorry?
Yeah, please go ahead. We have time.
Yeah. In case of power, right? I'm just trying to demonstrate you. So let's say suppose this drone is flying. That's wherein the drone is having a stability. It's a tricopter. In this case, the drone is having a stability. If I increase the power of the motors, the drone will be able to fly upward. Why? Because it has increased its thrust. But at the same time, it has to balance all those air gusts which has been created. So these balancing left and right, forward and backward is done by a controller called as PID controller. Those are actually designed these days by companies, but as an engineer, one must understand what is a PID controller. And when you get into engineering college, you will be studying those controllers as well. But if you are in the ATL, you should go and ask your mentor or any ATL in charge, what is a PID controller? How can I make one? Learn about those things. Learn about the math that is behind these controllers. Learn about the power of differentiation and integration behind these controllers. Try to understand all of those facts in terms of practical knowledge than learning or mugging up and putting it onto a question paper, answering them for a question paper. That's a totally different thing. Once you learn by doing, once you learn by experience, you'll be able to understand PID controller and the beauty of its capability and capacity in a very large sense. Let's proceed further. So now airworthy redefined as a cycle. The way I look at it, the way I as an engineer see airworthiness is like so. First, there are newer ideas, any idea that you might have, which we call as technology readiness level 0. That's a zeroth position of any idea that you might have of a drone. Then the idea stage, TRL 0 again. Then we go to a vision, which is TRL 1. What is your vision of designing a drone? What is the purpose of designing a drone? Why do you want to design this drone? Are there any other ways that you can solve this problem? So there are many aspects to which we think before we design a drone system. Then there is you tinker. As an engineer, being at, graduating from a college, after then going post-graduation, working with ISRO, I still tinker every day on my design when I work for them. I have to tinker as an engineer every day to make my design, airworthy. I tinker. So you as an engineer, you as a student will also have to tinker one day or the other, working your way out from this, designing these systems. Then there is the third stage, prototyping. Once you tinker, you have the design ready, you know the purpose, you make a prototype. And thereafter, you make a minimal viable product, which is TRL 6 or 7. 5, I missed it. Why? Because 5 is in somewhere in between prototyping and minimal viable product and going for funding, so on and so forth. And then after that, you generate revenue, TRL 7 and 9. And then there is industry engagement, TRL 9 and 12. And thereafter, again, once you have the engagement, you have the feedback, you validated your product, there are again new ideas, and then you redefine your drone system and you want to go ahead in your drone development. Again, newer ideas, ideas stage, then vision, thinker. All of this cycle continues within the industry. So thereby, I'm also trying to explain you, once you get into entrepreneurship program, or once you take the path of entrepreneurship, these will be things, these will be the concepts among which you will be investing your time for long parts of your life. These will be those key points. So I think I've done with my presentation. If there are any questions, you may proceed further and ask me anything in relation to drone systems and anything among my presentation as well. Thank you. Any questions?
You can either put them in the chat or just unmute yourself and ask the questions.
There are two things then. Either my presentation was very great, then there are no questions, or it was very horrible, that there are no questions.
There's one in the chat. What do you mean by strobe system?
Strobe system. Okay. So the strobe system is that those blinking of those lights of an aircraft. Have you seen? You must have looked out of your aeroplane while traveling somewhere. So these are those lights that blink very quickly. Those are called strobe lights. That system is also designed in a very has to be designed very in a very thoughtful way, because if it's having any problems, then the aircraft is deceived to be known as an aircraft. It's something else. People try to say it as an unmanned flying object, something like that. It has to be followed. There is a standard that is followed by the DGCA, and you will have to also follow the standard while designing those strobe systems as well. Other questions? Let me. Are there any questions coming on YouTube or somewhere else?
Nothing else. I see people complimenting the presentations. I think it was very comprehensive and covered most of the things people wanted to know. If you have a question later, maybe you can put it in the chat, and we can have Sir answer them again separately. But thank you everyone for joining in today and participating in the mentoring hour session. We'll be okay. There's one more question. Can there be a secondary fan for safety?
Secondary fan for safety, ma'am, in which situation? Are you talking about a drone system? As I said, the more number of even number of propellers that you increase, there will be an additive stability. But after, I think about 10 motors within the size of the drone has already exceeded 2 meters. Increasing number of propellers won't be increasing stability after certain values of number of propellers already there. So let's say suppose a quadcopter is less stable than an hexacopter, and a hexacopter is less stable than a octocopter. So in that situation, an octocopter with the same radius is more stable than an hexcopter or a quadcopter. Sir, can you throw more light on flight of aeroplane? What do you want to understand there? Flight of aeroplane. I didn't get your question very quickly. If the main propeller fails, sir, if in case you are having a aeroplane, in that situation, if one engine fails, you have secondary to another engine on one side. So in this case situation, there is an additive thrust in one direction. So in this case, the rudder is stabilizing that effect of moving the aircraft in this direction. In that situation, the attitude of the aircraft can be controlled. But if both the propeller fails, then there is a problem. Okay, flight of airplane, science behind it. Okay, I have tried to add a lot of information in this presentation. But if you want to learn more about it, there's a good book called Introduction to Flight. You may go through that, the actual science behind it, the flight. And if AIM requires another session, we can do that as well in the future stage, where we can talk about flight of an airplane. That's a good suggestion. So thank you. Okay, sir, how to lift upwards a drone? As you increase the propeller speed, the drone will lift up. And stability, if you're going with a RF frequency or a radio frequency drone, you're controlling it with the radio. In that situation, you will have to learn to make it stable. But otherwise, in our case, the way I designed, my designs are autonomous. In that situation, the controller on board can handle its stability. So if you want to lift the drone upwards, you will have to increase the speed of the drone, of the propellers or the motors. Thank you. Okay. I think we are done with the questions.
Great. Thank you again, sir, for doing the session and everyone else for joining in. We'll be back with another session next week. So stay tuned for that. Thank you.
Okay. Thank you everyone for having me. Thank you for listening. Thank you very much. Bye-bye.